We will talk a lot about the modularization of the application and how it works, how it may help you during the DevOps work and during the front-end engineer work. And this talk is basically a case study based on the Cyclon's one of the biggest projects in Cyclone, which is highly dependent on internet purchases and partner integrations. So basically everything that this company does, it does through the internet, and it has millions of customers and more than 350 websites around the globe. So what we will discuss today. First of all, what is the problem? Why is it so important? And what kind of issues we may encounter during the web application deployment? And those issues are not only related to the technical part of the web application, but also to the processes, procedures, and maintenance of those applications. Then we will focus on the modular web architecture security that we implemented on the project. So basically, it will be a kind of case study on this modular web architecture security and what tools and what stuff did we use during this project. So we will discuss the internet security part. So basically, it's how we configure Web Application Firewall and Content Delivery Network system. We used Akamai here because it's like a #1 in Gartner for the Content Delivery Network systems and for Web Application Security Firewalls as well. We will discuss the ingress solutions that we proposed to solve some issues that we encountered. We didn't want to have this ingress part, but we had to, and we will discuss why. And some additional tips and tricks on the API level that we also had to make decisions and had to think about how to secure this part of our application. There will be some other considerations, and at the end, we will just sum it up. So let's talk about web application components. I am talking about modern web application. Of course, it can be absolutely different. And the company I'm talking about was using a Java web application, which was huge and monolithic. So there is a system of... Sorry, something. There is a system called Hybris, which is Java-based. It's really interesting, but the problem with it was that it was monolithic. And when we are talking about 300 plus websites, there is a huge issue on deploying this Hybris solution, because if it's monolithic and different teams are developing different parts of the website, different views and different stuff regarding the website, there are lots of issues here on the deployment part, on the deployment side. So to mitigate that, we started to split up the application, especially the front-end part of the application, and we created the thing called modular boilerplate. Basically, it's a boilerplate where you can create your own website based on typical solutions with a typical CI/CD process, with lots of pre-configured stuff. And this modular boilerplate uses as a backend, it uses APIs, API gateways, or lambdas behind them. So basically, what we use in our modular web application, it's a boilerplate with our front-end application, with the generated static HTML code that is published on the website. But at the backend, we are using API gateways, which connects to lambdas, which generate the static code. Also, we have a static assets in S3 buckets, which also added to the boilerplate. So basically what boilerplate does, it gets all the necessary information, creates a static website, and publishes it for our customers. So what this approach helped us to achieve? Basically, the first thing is every endpoint represents every part of the business and every part of the development. Right now, this project has more than 50 developer teams working on separate projects. This means that if one team is like 7 people in average, this means that 350 people are working on different products, on different parts of the solution. And we can put every team there. So it's basically what it is, what we are trying to achieve and what we are moving towards right now. So this part is already in production, most of it, but currently we are adding more and more services, more and more parts and components of the business to this type of the architecture. So what is the problem here, and what kind of defense should we implement on this modular web architecture? So one thing that we need to implement, it's not about the web application security itself. It's more about processes and people. And one thing that we encountered during this project was the problem that we have not enough security experts in the teams. And basically, most of the teams are not focused on security at all. I mean that if the team has a backlog, they have features to deliver, they have like their management to push them, and they need to develop some kind of sub-website or some kind of website component, the security will be kind of blocker that slows them down. It won't help to deliver the actual business value for them. And most of the time, any security tasks that are coming from the security team to the development team, it appears in the backlog and never exits the backlog and never comes to the next sprint. So it's kind of a problem, and it's one thing that we had to solve with processes and with additional implementation of additional controls and additional processes focused on people. Another feature and another thing that we need to consider, it's a CI/CD process and the protection from supply chain attacks. Basically, we're using lots of libraries. We're using lots of public Docker images. We're using lots of external dependencies. We're using lots of cloud services and lots of tweaks and configurations. And what we need to do, we need to make sure that all of our teams, during their deployment, their code is secure enough, is checked against those dependencies, that we can find any dependencies that are not secure. And if there's any threat modeling system that is not happy with our current deployment, we need to fix it. And the third layer, it's actually outer layer. So here we are talking about Akamai and Ingress solution. And here we also have few problems that are not super obvious. One of the problem is that most of attacks, issues, and internet problems that our websites receive, they are not from hackers. they are from competitors and from parasitic companies that want to resell our services and our products. Basically, most of the malicious activity on our websites, it's bots and crawlers. So they want to get pricing data, they want to get product availability data, they want to get like some kind of logistic data, some kind of I don't know, discount information. So it's a business related thing, and basically what they do, they are not trying to break into our system. They try to use absolutely legitimate measures like opening our website and starting to create millions of search requests just to get this data from our website. For us, it's a problem, not only in terms of business, because we want to hide our pricing information. It's not the main problem. The main problem here is that our legitimate customers that are opening the same website experiencing some delays, some performance issues, and sometimes it's like we have more crawler traffic, like 10 times more crawler traffic than a legitimate user traffic, which is a huge problem in our case. Another problem, it's a manual whitelisting of things. So basically, let me explain how it works and why is it important. We have lots of partners, we have lots of legitimate bots, we have lots of companies who resell our services on our behalf. And those companies are so so they have their own logic, they have their own data, they have their own bots and crawlers and ways to authenticate, ways to get this data. And sometimes, for example, we may allow some kind of client or some kind of partner to crawl our data, but here we have two problems. One is from the process side. So basically, they contact our marketing, and our marketing contact security team, which creates a whitelist for this exact company. And when we have like 10,000 of whitelists on 300 different websites, it started to be like a knowledge silo, because no one knows why this IP address is whitelisted. No one knows why this bot behavior or this token or this part is whitelisted, etc. So we have lots of manual processes here, unfortunately, and we need to have measures to automate this or somehow to unify this part of the configuration. And another thing, it's a regex problem. So I will also discuss it in the future, because it's one of our solution, and we had to make like a non-optimal decision here because of this regex. So basically, our backend has network paths and network domains, different network domains for our backend services, for different backend configuration, for different parts of the boilerplates, for different APIs. And on the website, we have a path. So when you hit the URL, this URL is getting transformed on the ingress. It's getting transformed to a backend based on what is written in URL, or we receive a backend name and connect to this web component. The problem here is that if it's dynamic, it can be exploited. So we can put some kind of injection attack into the URL, We can overload our system like with non-existent domains that our DNS server should resolve. We can do lots of malicious stuff that are not okay. So basically, when we were thinking about this regex logic, we encountered that we cannot fully automate this, and we still have to whitelist everything that we have internally just to protect our internal system from some kinds of injection attacks. So let's talk about solutions. So first thing that we created, it's a process and people part. We designated a security champion for every team. Basically, security champion, it's not a security expert. It's not a profession, it's a team role. And the main responsibility of this security champion was to basically take care of the security questions and be the person who pushes the security agenda during the sprint planning, refinements, etc. So basically, it's a person who cares about security of the component he delivers. But any engineer from the team can be a security champion. It's not like it should be only a DevOps engineer, because some teams just does not have DevOps engineer. It's not the security expert by all means. So it can be a front-end engineer, a back-end engineer, some kind of developer, database administrator, anyone. It's just a person who cares about security topics. And security champions, they have community. They exchange the information between, they exchange the best solutions between them. And when we change something on a global level in terms of security, well, we can connect with security champions because it's their topic, and not just announcing the changes to everyone with additional meetings when we have already like millions of them, but to have only an event dedicated for security champions who care about this topic. And the second part of this solution, it's a common tool set and common baselines, common practices for the whole company. So basically, you are free to choose any delivery language that you want. You choose to actually provide any type of services and use any type of like cloud services that you know and you think that it will solve your problem. But there are baselines, there are tools that should be implemented on your part. And there are practices that are common for the whole organization, minimal requirements and best practices that are recommended for lots of scenarios. And if we're talking about common security tools that are mandatory in the pipeline or that are mandatory during the deployment, there is an audit system that is auditing the usage of common security tools. So we are making sure that every CI/CD pipeline, every repository has security tools in place. So let's talk about those security tools. So we implemented a part of the pipeline called Application Security Pipeline or AppSec pipeline, which basically can be included in every CI/CD as an additional step. So when you develop something, you can include in your CI/CD pipeline another YAML file, and in this YAML file there will be like additional steps to the pipeline which are mandatory for every team that is delivering something, which is mandatory for every repository that we have. And this pipeline is actually a quality gate with a hard stop. So basically, if any of these tools is not happy about security, the pipeline will fail, and you will have to resolve all the issues that you have on the pipeline. So when we implemented this AppSec pipeline, we implemented it gradually because every tool started to find like hundreds of issues, and developers and DevOps engineers, they had to actually act and to change the configuration, to change the code, to change the libraries they use, to change Docker images they use, to make sure that they're using newer versions of those libraries. And actually, so it created a disruption. So to make this disruption to come easier, because like we have at least 5 tools that are checking the security part. Yeah, and every of this tool will find at least something. So not to completely block the team's work, we had to do first time it was a soft stop. So basically, you received an warning and quality gate allowed the pipeline to proceed. But after a period of time, we made it a hard blocker. So everyone should resolve critical and high-level issues that they have during their test. So what types of tool do we use? OWASP Zap as a static code analyzer, which checks the code against the most common security issues. For infrastructure as a code, for the Terraform part of the code, we are using Checkov, which analyzes the Terraform. So to make sure you are not opening too much ports, or you are not creating a role with too much permissions, or you are not doing something non-secured. And it's mandatory because sometimes parts of the infrastructure are managed not by DevOps engineers or security engineers, it's managed by developers themselves. So Checkov is a mandatory part. Also, we have SonarQube Quality Gate here with OWASP enabled as well for the whole code. And we have tools that are analyzing Docker images like Docker and Trivi, that analyzing Docker images for security and for best practices of using Docker. So this application security pipeline allowed us to actually make sure that our CI/CD process is more robust, more secure, and more protected from the supply chain attacks. And the next part is actually related to web security, to the internet part of the security. So we have an endpoint for the Web Application Firewall and CDN. It's an Akamai solution. Also, on the cloud side, we have Ingress solution to hide internal naming and services and all the backends that we use, because before, every bot was able to connect with the proper URL, was able to connect to some kind of search service, to some kind of database, backend, API. So it was a disaster, and we got rid of it, and we made sure that only front end is able to connect to it. So the Ingress solution is an additional layer of security to hide all the API endpoints that we're using as a backend. Also, all of the backends have the internal private DNS zone, and the name resolution is done by the private Route 53 DNS service. Yeah, we have a regex-based solution for internal routing, but it's a bit restricted. And one thing that we had to choose a non-optimal strategy is basically this regex-based solution for the routing. So I will talk about it a bit later. And for backend communication, there are GraphQL API endpoints, REST API endpoints, depending on the backend itself, but we are currently moving to GraphQL more because GraphQL allows us to get the better view on the information and be more flexible in terms of which information to provide depending on the request. So let's speak about those components more. So first of all, it's Akamai. I didn't want to make this like an advertisement for Akamai, but the product is really cool, and I really was happy when I met it and when I started to deep dive into it, to get the information from it and to get the configuration and all the stuff. So basically, it's like a spaceship in terms of web application firewalls and CDN. So Gartner gave them the first place in terms of like technology and completeness of vision, both in web application firewall and CDN solutions, for a good reason. So to the right, it's one of our websites with all the modules that is present from Akamai. So there are lots of features in Akamai that are helping to protect and to cache and to improve the performance of the website. But what is the most important things that we have? So first one is, of course, bot detection and control. So Akamai can detect legitimate, non-legitimate bots. It can whitelist bots. It can allow some kind of bot activity. It can also intelligently detect some kind of activity to make sure this is a bot-like activity because, for example, because of throttling, because of number of requests, because of the patterns that it uses to connect to some kind of services, because of search patterns and some search components of the website, because of headers it search. So basically, the bot detection system is one of the best on the market, and it helps us a lot to identify malicious activities that I already described. Also, one feature that you can also use on any other web component, but here it's also very handy when you are writing the errors that website receives from the backend. So basically, if you have like 502, 503 errors, you may not show them to the customer. So the customer will receive 404 errors instead. And you will still have the logs on your origin, on your website itself. You will still have all the logs. You will still have 502, and you can analyze it. You can still fix that, but your customers shouldn't know about that. Also, the dynamic traffic control. So basically, it has throttling, it has performance stuff, it has like ability to prioritize type of traffic, so legitimate traffic over non-legitimate, etc. It has its own captcha solution, but the one feature I wanted to tell you about, I really loved it, and it made a huge difference. It's relatively new on the market and relatively simple, but this feature actually changed a lot in the business and in the website that is protected by Akamai. This feature is called Crypto Challenge. So basically, what does Crypto Challenge do? It's a captcha-like challenge, but instead of asking if you are a human and you can select all the traffic lights on the picture, which basically can be done by bot more easier than by the real human, it makes your browser to mine for hashes. So basically, it loads your browser with some kind of calculation that takes the processor time, that takes basically some time to load the page. So what is the feature here? If we are a normal user that uses the browser, we will open a site like few milliseconds later. But if we are a bot that generates 1,000 requests per second, we will have to calculate this on every request, and this will basically stop the bot from proceeding. So if bot is able to calculate it, it will calculate it on every request, but if it will not be able, the bot won't pass our captcha, so it won't pass the crypto challenge. When we implemented this, we were very careful. So first of all, the loading time of the website is a very sensitive number, not only in terms of satisfaction of our customers, but also in terms of SEO, search engine optimization. Because search engine, during the Google request, for example, Google sorts our pages based on the opening time of those pages. So if we are losing like 1 millisecond, it may not affect this, but if we are losing 100 milliseconds, it's already a problem. So we were super careful, and we enabled it on a first test website. So, and checked like for more than 1 month what is going on this website. And the results were fantastic. So the reduction of the traffic was like 5 times. So basically we received five times less traffic on this website. But the number of users that were buying stuff on the website, so the number of purchases, the actual marketing numbers, they didn't change at all. So basically, we just got rid of the 80% of the traffic without affecting our users and without affecting our business. So this is the crypto challenge. One feature, one small checkbox that changes a lot. And another important thing that I wanted to say about Akamai that we used, it's infrastructure as a code with Terraform and APIs to make this a part of our pipeline. So basically, if we are deploying everything with infrastructure as a code, we wanted to deploy Akamai configurations also with Terraform. And it's possible. So Akamai currently adding more and more features and services to the Terraform, and all new features that Akamai develops, they are developed with Terraform in mind. So basically, Akamai is moving also very fast towards the infrastructure as a code. But like every good product, every super good product has its own issues. And one issue of the Akamai is that it's too good actually, because there are too many configurations, there are too many settings, there are too many options that we can choose from, and it's a bit hard to educate a support specialist or a DevOps specialist who will manage the Akamai service. So it's a kind of buzz factor for us for now, because we are educating lots of people to use Akamai just because it's hard to get all the information. But what else do we have here? So one problem here is legitimate bots, basically whitelisting that I already told you before. So when we have a good bot that we may allow, we need to somehow whitelist it, and we can whitelist, for example, an IP address or IP address range, but it's not okay for every of our partners, because some partners can change their IP address range when they're using bots to crawl our services. So basically, this whitelisting, it's one of the tasks that takes like almost half of the day of one of the engineers. Property management. So every Akamai configuration, every Akamai website is called property in the Akamai. And the problem with the property management is that we cannot yet, for example, for now, we cannot delegate permissions on a property level yet. Or we can delegate permissions on a property level, but this will mean that a person can edit all the properties, and sometimes in one property there could be like few websites, and it's super hard to manage role-based access control and minimal permissions that is needed to actually edit the Akamai configuration. So basically, it creates additional overload on Akamai support team because they have to do it instead of engineers that are deploying something. And if we're talking about infrastructure as a code part, it also creates additional overhead because basically our infrastructure as a code system can do a lot more than we want it to allow. But there is a thing that can help us, and Akamai brought us a feature that can help us. It's called a PM includes. Basically, it's PM, it's a property manager, so it's for the properties. And this PM includes, it's basically an additional configurations over the property. And with those PM includes, we basically may delegate teams to change the property configurations without giving them full admin permissions on the website. Just make them able to edit their own PM include part. And the property will manage all the PM includes that this property has. So when a few teams are working on the same websites but on the different components, they can use their own PM include to change their part of the configuration that they need without affecting other teams' work. And this helped us to actually manage everything with infrastructure as a code with Terraform. So that's why we're talking about infrastructure as a code consistency. Also, one thing that is hard in Akamai is to educate front-end developers, just because Akamai uses its own caching headers, and front-end developers need to know how to cache their components. So basically, if they want some components, some part of the website to be cached in the CDN in the Akamai, they need to put it into their code on the HTML headers that will be used by Akamai. And we need to educate front-end developers on how to do this properly. The same applies to cache invalidation. So if something is cached in Akamai, we don't want, when we redeploy a newer version or generate a newer version of the HTML page, we want Akamai to invalidate the previous cache and recache it again. Now, another issue I already told about it, it's manual tasks. So lots of stuff has been done manually. And here we have some additional overhead because, for example, lots of our whitelists, lots of our things, they are very manual and very problematic to mainstream and to make it automatable, because lots of the stuff, so we see the malicious traffic, we remove it. So another component of our security part, it's security ingress. It's a pretty simple solution. It's just a reverse proxy with a private domain. So basically, when we hit a URL on the website, it goes through Akamai, it goes through application load balancer in the AWS, and comes to the Nginx proxy, which uses private DNS zone to the name resolution. And then it proxies the request to the service.domain.url, so to some kind of endpoint that it uses as a backend. So here we also had a few solutions to be made, and one solution that is not optimal because of the security consideration. This is a regex based name resolution. So what is the problem here? Basically, we have a part of the service and domain in the URL of the website. And one scenario that we cannot handle, basically, it's when we put like 1,000 of computers, 1,000 of unlegitimate IP addresses that will randomly open non-existing domains, which will create a traffic to the private DNS zone from our cluster and can potentially disable the private DNS zone. Basically, Route 53 provides like a limit of 5,000 queries per second. So in this scenario, basically, if we will create the traffic more than 5,000 queries per second with negative responses for the DNS, it may disturb our service, which is absolutely not okay for us. So instead of the regex-based name resolution, we had to basically whitelist all the names that we have. And this added lots of additional overhead to our deployment process, because before that, we thought that, okay, if the team is deploying additional backend, we just use an additional URL and everything works perfectly because we have this regex. And now if the team adds additional domain, we have to redeploy this configuration for the Kubernetes cluster and to change it because of this additional name. So we wanted to make it like as easy as possible for the team to deliver, but due to the security consideration, we couldn't do this, and we had to whitelist every domain that we have. Just because of one of these scenarios, and there are also additional scenarios like putting some kind of injection code into the URL, which will be processed on the Nginx side, which is also absolutely not okay for us. So we had to whitelist every URL that we have internal. So here we are talking about this ingress issue. So one of the issue I already told about this, it's a DNS flood attack on the regex. So basically, if we are using fully allowed regex, it will create this type of vulnerability, this type of threat, which we don't want to survive. Yeah. And also we put alerts on the DNS server, alerts on the Nginx side, so we have the visibility if something malicious is happening on the DNS resolution side as well. Not only on Nginx itself, not only errors of the processes and on the application. Also, this ingress affected performance because it's a reverse proxy and it doesn't do any SSL offloading. So basically, it has its own SSL certificate, all the stuff. And here we also have additional performance consideration because this ingress affects performance, and we had to do end-to-end tests. We had to enable scaling. We had to cache lots of the stuff on the Akamai side, and some things allowed to cache on the regex side. On the ingress side, but it affects performance, and we had to optimize this performance more and more to make sure it works well. And as I told, during the new service deployment, we have additional dependencies. So we have additional change that needs to be done, not in the pipeline of this new service, but in another pipeline that manages this regex. So basically, we wanted to make a absolutely transparent service for the developers, but due to security, we had to put this at stop and have additional dependency, which is unfortunate, but security is more important in this case. And the last but not least part, where we also had lots of questions to ask ourselves, it's an API level, it's a GraphQL level. Still, if you know the proper URL, you may try to query the GraphQL directly through the known regex and through the ingress and all the stuff. It became harder, but as far as I understand, it's still possible. So we made GraphQL not to answer for such a request if they went not through all the systems and not checked by the crypto challenge. And another thing that we had a holy war on. So basically, to the right, you can see the GraphQL query that will query the GraphQL endpoint for its schema. Schema, it's like how the data is structured in the API server. So basically, what kind of data we may extract from the GraphQL endpoint if we want to. And the holy war is that we may publish the schema, but it makes this configuration less secure. Or we may prohibit publishing the schema, so this query will not get the answer. And some developers, so security specialist was against it. Developers was they wanted it just to make things simpler. So basically, right now, it's up to security champions on each GraphQL endpoint. Again, the question, should we allow bulk operations on our API endpoints, and how can we control it? How can we actually block malicious or too big bulk operations? It can be controlled on any level, like on the ingress, on the Akamai, on the API level. And the question is, on which level should we control that? Because it's easier for developers to control it on the application level, but it's easier for the security team to control it on Akamai level, for example. So another holy war and another WOG question which we had to compromise. And compromise is when everyone is not happy. And another question was, what is the throttling level? So basically, how many operations per second can we allow on the backend, and how can we control this? So basically, we have alerting there, we have metrics, we have monitoring, which gives us all the information here. But the question is still, how many is good? And the answer is different for every website, because some website has millions of users per day. Some websites have 1 or 2 users per day. It depends completely on the website. And other considerations. So one of the considerations was traceability. Basically, one thing that we are working on right now is to add some kind of header or some kind of token which allow us to trace every operation that is going on our website back to the backend, back to the database parts, back to the APIs that we use, just to make sure we can trace every operation that happened during the day to investigate malicious and suspicious activity. So basically, which user, what happened on one website, what happened on second website, what happened on one API, on second API, and what returned to the user. We need to trace this whole operation, even in distributed system, because the system currently is being developed by different teams, and those teams are independent, and sometimes they don't know each other. But we need to trace the whole operations through all these applications. Yeah, another hot topic and hot question, it's caching, what we are caching, what we are not caching, what kind of caching do we use, how we invalidate, how long should it cache, how long should it be cached on the user level, on the browser level, how long it should be cached on the Akamai level, and other stuff. So it's also a super hot topic, and right now we are still considering this and still having those questions. And headers, yeah, it's related to these two things. So which headers are we accepting, which headers are we using, and what are the best practices of using headers in the traffic. So to conclude everything, I would say that complex tasks require complex solutions. So basically, it's not that we have a super tool that will solve all our problems in our life. Unfortunately, it doesn't. You still have to consider, you still have to compromise, you still have to do a lot of meetings and discussions with different people, with experts in different areas, because changes in security area may affect all the stuff that related to the business. But in terms of our solutions that we came to, we built it on few main principles that are used to actually drive the business. So one principle is a team independence with centralized tool set and centralized best practices. But the team is more or less independent in their part. So basically, team just focuses on developing their own features and developing their own part of the solution. GitOps approach for all services. So all services are built with infrastructure as a code. All the changes in the infrastructure is done via the Git, and there should be no UI changes, there should be no opening the console, etc. So only through the Git, through the whole process, through the merge request, through the feature branches, etc. And of course, layered security. So security, it's not like a firewall or something. Yeah, it's lots of processes. It's we should consider security from the very beginning, from the idea of our service, during the development process, during the deployment process, during the maintenance process. So we have lots of security considerations, and security is one of the most important parts of the business. And as I told, again, it's not only about hackers or GDPR or something, it's also about the business, about the malicious bot activity, crawlers, getting the data, getting the prices, getting the promotions, etc. For competitors or for parasitic businesses. So basically, it's not only hackers that creates us a security problem.